Video, we're going to look at topic 83, example 1, identify even and odd functions from their graphs. So up top here, we just have an example of an even function, an odd function, and something that doesn't qualify as even or odd. So even functions, you want to keep in mind here, for all x in the domain, f of x is equal to f of negative x. Basically what's happening here is your graph is symmetric about the y-axis. So if we were to fold the graph in half, the left and the right sides are identical. And we'll get into a little more of an example of how to test for that in the actual example part A, B, and C. An odd function for all x in the domain f of negative x equals negative f of x. So what's going to happen here is your graph is reflected across the origin. So, or if you rotate the graph 180 degrees, if you were to like spin it around, you'll get the same graph. Okay, so that would be an odd function, is if it's reflected about the origin. And then if it's not reflected over the y-axis or the origin, then it would be neither. Okay, that just falls into kind of the obvious sense there. In 83.1, identify even and odd functions from their graphs. Use the graph to classify the polynomial function. Is it even, odd, or neither? So one of the things that you're going to want to do is pick a point on the graph. So this point here, I have the point 1, 1. And what I want to look for is that reflected across the y-axis? So is that here? Then no, so this can't be even. But if I pick this point down here, that point is negative 1, negative 1. Notice how both my x and my y are opposites. So what that tells me is that this is going to be an odd function. So if you were to take this here, and you will rotate around, so if you were to spin any of these points 180 degrees, you get the same graph. All right, don't overthink this. Check your points. If both of them are changing, then you have an odd function. And again, it's spinning about the origin. Okay, 180 degrees about the origin. In part B, again, pick a point that you can see on the graph. In this case, we have 1, 2. That point would be reflected on this side, and this would be negative 1, 2. Notice that your x values are the opposite, but your y values have stayed the same. So this is your signal that this is an even function. It's reflected. If I were to cut this in half over the y-axis, this left side is the same, or reflective of the right side. Okay. Try not to overthink these. Just look at whether it's being spun around 180 degrees about the origin, or if it is reflected left to right side. In part C, again, let's pick a point. I have this point 1, 2. Now, if I were to reflect that across the the y-axis, this point over here is negative 1, 2. So that point obviously is not along that red line, so that tells me it is not even. And if I were to change both of these, so the x and the y values to the negatives, make them negative 1, negative 2, that point is also not on my graph, so this one would be neither. So let's write that in blue. So this one is neither. Okay, I'll say it one more time. Don't overthink this. Compare your points. If it's a reflection, so here, if your point reflects left to right across the y-axis, you have yourself an even function. If it's an odd function, it will be spun about the origin 180 degrees, and then if it does not do either one of those things, we're going to select neither.